I'm Sean Sadamore, and good morning, good afternoon, good evening, wherever you are in this lovely blue planet, third rock from the sun. So happy to have you here, and great to kick off a 101 with Michael Hindle. And we'll get things started with Michael, but it's just great to see everyone. It's been a while since I've had sit in the control center here at Passive House Accelerator, and great to be here. So I hope that you're in your comfy seat, you got a beverage, could be a warm cup of coffee, or might have been old school root beer. So whatever you're doing, sit back and enjoy, because Michael Hindle, he is the MFA Certified Passive House Consultant, founder and principal of Passive Positive, a building closure and energy efficiency consulting firm specializing in passive house, zero energy, low carbon, and resilient design. One of the nation's first certified passive house consultants, Michael has worked across multifamily, mixed-use, retrofit, and regenerative design projects with a focus of low toxicity materials, carbon sequestration, construction methods, and community-led development. And we're going to hear about an example right now. Michael, over to you.
Hey there, thank you so much. I guess it's time to share. Um, First, it's exciting to see that I don't recognize many names. There are a handful, you guys, of course, but mostly new people, perhaps, or at least people I don't know yet. It started out as such a small community, and every time we had an event, everyone knew each other. But now that's really changing, so that's exciting. Largely thanks, I think, to folks like you at the Passive House Accelerator. So thanks for your awesome work. Okay, I'll get right into it. So yeah, I founded Passive Positive back in 2010 under a different name, but same thing. Um, and these are my fantastic employees. We're going to become a co-op, just to link back to your reference to regenerative economics, Sean. We're going to become a co-op. We're in that process. So everyone will be an owner and a vested interest. But in any event, this is our company. We started out my very first project in 2009. I was like fresh out of the art studio where I got my professional training in art, and straight out of the studio into being a CPHC. A NASA scientist called me, and we did this Living Building Challenge project. That was my first one, and we got to do the first passive house apartment building in the country, which was a wrap in Washington D.C. in 20. That was occupied in 2015. This was before the sort of tenant in place stuff, so we were doing this experimenting. We've had the opportunity to do a lot of fun stuff. All of our projects from the beginning were aiming at being foam free, zero energy, and this is an example of that. And we're working on a whole bunch right now of multifamily and multifamily senior housing in particular, and almost all affordable housing. So everything you see here is affordable. We have this great opportunity. Now we're doing some district geothermal projects. So this is Barry Farm in Washington, D.C., and 200 unit apartment building or sorry, 139 unit apartment building and 93 townhomes are being put on a district geothermal loop. So that's a presentation I'll be giving at Massachusetts Passive House in a couple of months, but it's a really fascinating topic, and I feel very fortunate to be working on that as well. The other thing, Sean, you also mentioned when we were pre-show discussion, turning the passive house conversation towards resilience as well. And so we're doing a whole bunch of critical load assessment for resilience cores, resilience hubs, and we're doing the dynamic simulation. So we do passive house WUFI modeling, but we also do dynamic simulation in IES for hourly loads to judge battery backup, state of charge of the battery, the loads that we define as critical, et cetera. So we're having a great time. We feel super privileged to be doing this work. But that's not what I'm talking about today. Today, we're going to talk about mass timber and passive house. And so I would be remiss without calling out some of the teams we've worked with. I'll be talking about two projects, 11 East Lenox in Boston, Mass. And the team there, you see here, it was Breck, Boston Real Estate Collaborative, Monty French Design Studios, H&O, the structural engineer, very good collaborator, and Haycon Construction. Incredible team, did wonderful work. I'm going to talk about that at some length. And then also 79 King Street in Northampton, Mass, which has not been built yet, but I'm glad to know that it's alive, and we're going to be returning to that project soon. And that's with Jeff Spiritus, who this audience heard from last week. And he's here today, so I hope he'll chime in and correct me if I make mistakes. No, but Jeff's been a great collaborator as well, and a really a leading light in this arena. So I'll start with 11 East Lenox Street. It's a beautiful project. It really is. I just feel very, very fortunate to have worked on it. Watching it come together was actually joyful. For all the reasons, Zach, that you mentioned in the video, it's a low energy passive house building. It's all electric, and we're using low embodied carbon materials. It's really a thrill. So there's a lot of data on how much carbon is sequestered, et cetera, which I'm going to get into more, but I just want to run through the project sort of at a high level first. We had a wood podium in this project, which is exciting. And sort of showing how we were able to fit in our mechanical systems within the floor plates. But I want to talk about some of the synergistic benefits between passive house and mass timber. One of the things that people will often say is, oh, there are these thick beams. We can't get the floor to floor height. We can't do this. We can't do that with mass timber. And that's actually, I've watched it kill some projects. But if you do holistic integrated thinking from the beginning, you can actually get around those obstacles and make them assets. In this case, it was in Boston. The ground is fill, it's uneven quality. And so they were able to make their building a lot more lightweight with mass timber. And they were also able to deploy this double beam strategy, which I'll show you in a little bit. So we did not have really deep beams driving up the floor heights. So we were actually able to compress the building 7 stories underneath at 70 feet. So it didn't go over the high-rise designation, which would have triggered all kinds of other code requirements. So this building actually penciled out because it was passive house, not in spite of being passive house. And it penciled out because it was mass timber, not in spite of it. But either one alone wouldn't have worked. So that was actually like a dollars and cents hard-nosed developer decision, like, oh, this pencils out if we do these 2 great things. So we were able to get it under that high-rise designation. This slide just basically says the same thing. But one cool fact was they were building on this Boston Harbor fill, basically, and they needed to lighten the building. And so they did so with mass timber. And then they were going to use these mat slabs, but they were still going to have to drill these incredible helical piles down until they hit bedrock, except that we were able to use lightweight fill over the mat slab and then float the first floor slab on top of that and use minimal foundations, minimal helical piles. And so we saved a lot of money. And they said, gee, what are we going to use? And I said, geez, there's this stuff called foam glass. And they're saying, hey, could we give you more of it? And I was like, yeah, sure. So we did not need the R value to have an 8-foot thick, bed of foam glass, but it was actually lightweight aggregate fill that they use for, highways and such. And we use for insulation. It worked beautifully to lighten the load of the building and float it basically on top of inadequate soil. Whoops, I apologize. This slide is a mess. Let me just skip forward here. Okay, one of the benefits. One of the benefits. There we go. Whoops. I'm going to have to hold on a second. I apologize, folks. This slideshow got a little messed up. Give me one sec, Kim. I'll be right back, okay? I'm not going anywhere. I'm just going to.
The layers you're talking about here, Michael, are just fantastic. So
yeah, well, thanks. I'm sorry about this.
A pause and check in with all the fun details you got going on between mass timber and the passive house component. So,
all right, let's try this again. Okay, one of the synergistic benefits. One of the synergistic benefits was that we were able to use small mechanical systems because it was a passive house. And so we had very shallow depth of our beams in order to get under the 70 feet in order to make the project pencil out. But we were able to do that because our systems were so small. So we did use decentralized systems in ERVs where we might have otherwise used a district or a centralized ERV, but this worked really well. So we used dedicated ERVs per apartment. That's not what we do on every project, but for this one, it works. This shows that double beam detail I described and the mechanical penetrations that were required. Now, of course, this was all pre-manufactured and delivered on site. So all of this stuff was worked out in advance and it went together beautifully. And I've got some pictures of that. The CLT podium was exciting. We have parking under this podium, but we did not go to concrete. And this gives you, this also shows you how the double beam structure went together and how it connects to these prefabricated metal concrete forms that remain in place as the towers for the elevator and the stairs. So that was an interesting detail. So it was prefab. It went together quickly, and then the timber was able to come in also very quickly and build around it. And these are just some pictures of how this all came together. You can see these beautiful, I don't know if you can see my cursor, but these beautiful cuts were already made. And so then they were just able to slide these small ducts for a small mini split and small ERV penetrations through. And we only had a handful of them. We did have some steel just on the garage level to make sure we had turning radius so the cars could come in and, eliminated a couple of those timber posts. But otherwise, there was no steel structure. It's just that small bit. So often we run into the question of like, well, how do you actually do mass timber? There are so many columns. Actually, we found it can work very well. I will say that one of the lessons learned is that you need to start integrating as soon as possible with the concept of mass timber so you don't design yourself a bunch of obstacles that you then later have to overcome. I think we could come back to that. And since Jeff is here, he might be able to weigh in on that as well. But here again, you can see the floor decks going on. These columns actually bear directly on the column below, and then the beams sandwich on either side, and the CLT is laid on top. So you can see this all coming together. I forget the exact statistic, but it was something like 5 union carpenters in just a couple of weeks to put up 7 stories. And most of that was done in days, right? Beautiful details, beautiful to see it come together. Talk about craftsmanship, Zach, you mentioned in your primer, like this was really craftsmanship and it was a joy. Okay, so the second project is 79 King Street, Northampton, Mass. This project is one that I'm very pleased to be working on with Jeff Spiritos and BKSK Architects. We've actually added a floor to this. And it is really cool seeing how all the sort of BIM comes together on these. And it's going to be beautiful. One interesting fact about this is that we're going to use CLT cores, and we're going to be able to leave a lot of the CLT exposed. So we'll have a reduction of finishes, which leads to a reduction of cost because we can leave the CLT exposed. People like it better than drywall anyway. And so we're reducing costs and environmental impacts. So all the exterior walls and half of the ceilings are exposed CLT. Some of the ceilings are enclosed just for that minimal ductwork that we're running, right? 120 unit multifamily. In this size building, we're saving 7,516 sheets of wallboard and 8,180 pounds of paint. So I've recently heard a statistic that something like 1/3 of our plastic waste in the ocean is actually latex paint. So after I heard that, this really mattered to me a lot more. The other really interesting fact of this is we are using CLT for the elevator and stair cores. And if we do that, we would, instead of using the concrete and steel, we would be able to save 276 cubic yards of concrete, all of the steel forms, and we'd add 106 107,000 kilograms CO2e carbon storage. So making decisions like that also is really powerful for the more holistic sustainability goals. In this project, well, now actually I'm going to do a couple comparisons. For 11 East Lenox on the left, you can see the VRF system. Lots of refrigerant, and we know refrigerant is an issue for climate change, but it's a very efficient system. On the right is 79 King Street, and we're using a combination of a VRF in one section of the building, and then we were working on using the EFOCA units in the longer wing of the building. Since that time, I had an experience with EFOCA, which gave me some pause, but I think they've really worked out a lot of those issues, and they're coming on strong. And we know some friends in the market who've used them and been quite happy. So we're going to be revisiting all these decisions because this was pre-COVID, but or during COVID. But we are excited to move forward with this design. And I think the unitized HVAC really would do wonders for this kind of building. One of the biggest obstacles we had in meeting with people about using mass timber on projects was everyone was assuming we're going to use a big DOAS unit and we needed huge ducts running through hallways and you need to penetrate those ducts. You'll notice on the left-hand lower diagram here, the beams do not cross the building. So what we didn't have much head height, right? Because we were staying within that 70 feet. But by stopping the beams on either side of the aisle of the hallway, we were able to run everything we needed to that was shared in that hallway. Now, mind you, that was not shared HVAC. So we didn't have huge distribution ducts either for ERVs or for, there wasn't a lot of shared distribution. It was line sets for VRF and some fire protection, perhaps, things like that, but none of it had to be the HVAC because our HVAC was so small by virtue of doing passive house. At risk of being a little redundant, I know I already said that, but you can see how it all fits together into that half of the ceiling in 11 East Lenox, and that will happen again at 79 King Street. Yes, we did have drywall over the bathrooms and the kitchen, but that was it. And all of the distribution could happen in those small penetrations. For hot water, these are all electric buildings, so they both have the Sanco CO2 heat pump water heaters. Now, you can see on the left, this is 11 East Lenox. This is half the floor plate, okay? This is the L at the bottom, this at the southwest, and then the northeast would wrap around the other way. But I just wanted to show you one quadrant because we were able to use heat pumps. Are you able to see my cursor when I do this? Okay, all right, so I'm sort of gesticulating digitally here. The heat pumps are mounted on the underside of the balconies, okay? And then the heat pumps connect to a shared tank that serves 1, 2, 3 apartments. And the distribution lines, we were able to keep very minimal by, staying within that limitation on the volume of water you can spill if you're doing passive house. And this being 101, I think probably people have heard it, but we can't spill over 0.6 gallons of water before we feel that 10-degree temperature rise. That's so we don't just waste a lot of water resources, right? And a lot of heat getting lost by virtue of sitting unused in the pipes. So we have a recirculation line with on-demand sensors, but it's for this very limited run. And then there are short runs from there. And the planning of the fixture location and the tank location was sort of predicated on that. So there's another example of let's integrate early and talk this through. On the right, we have 79 King Street, and this is a larger building. The footprint of it is quite a bit larger, and more than 3 times the number of units. You can see we have a couple of storage tanks and a swing tank in one location. And so what happens is we have a large storage volume and then swing tanks that go off to recirc lines that go around one wing of the building. And so you can see one is at the knuckle of the bend in the building. It's like the number 7 on its side. And so at the knuckle, we have a tank and swing tanks, and the heat pumps are located down in the garage, below the podium, and on the roof. So there's a cluster of heat pumps on the higher up and down below, and all the floors are fed between. And then the circulation loops just run along the corridor, and the fixture end runs just tap off of that. Okay, so to get a little passive housey about thermal properties, another synergistic benefit of using passive house and mass timber is that passive house likes to reduce heat loss for overall energy, and timber accommodates by reducing thermal bridging. So where in the past you might have had a steel structural connection, now we have wood. So you can see on the left, we have basically what I did was I modeled the building as if it had a concrete deck with balconies. And we all shake our heads and say, no one would ever do that. And then you walk outside in a city and you're like, oh, everyone does that. Oh my God, the building is a radiator. Well, so I modeled it as if it was designed to be concrete and steel. And it was astonishing the amount of reduction of just using mass timber. Forget the continuous insulation or the proprietary thermal breaks, none of that. It was just like using timber instead of concrete and steel. And it reduced the heat loss at those junctures by 92%, and it increased the interior surface temperatures by 12 degrees. Now, what does that mean to everyone? I think, even though it's a 101 passive house talk, everyone's like, oh, increasing surface temperatures means not just am I more comfortable, because the mean radiant surface temperature is a little bit higher, and not just did I not lose a lot of money in heating energy out the thermal bridge, but also there's nowhere near the risk of condensation or above 80% relative humidity air at this corner where my cursor is. 48.2 degrees is below the dew point of interior air. And this, it's 60.1 degrees. Okay, and this is the mass timber side, right? So in other words, we've raised the interior surface temperature above the point where it could ever grow mold. Now, I have been in plenty of projects in the Mid-Atlantic and in Boston and other places where you have masonry construction with steel pocketed or concrete dead ending into a masonry wall. And these are very real challenges in retrofits. We've done a lot of retrofit too, and they're really fun and really challenging. It's another conversation, but this surface temperature of corners with structural connections is a very serious issue. All right, so if you improve, these are the actual heat flux thermal bridge models from this project, shifting to mass timber, including the doors, which were Amberline, very nice product. They had aluminum products and UPVC, so that was a great partnership. In any case, this is that COVID era construction site visit with Nessie Pro Tours. But if you can eliminate the risk of condensation and the risk of mold, you're improving your indoor air quality even beyond what Zach already mentioned with respect to bringing in filtered fresh air, which has also been heat exchanged. So you don't have, I've even been in buildings where you have air coming in, blowing against a wall, but it wasn't heat exchanged, Zach. And so mold was growing against the wall because they were bringing in ventilation air. It was cooling the wall surface down, but the relative humidity was high because they didn't have the enthalpy exchange, and they grew mold on their walls by ventilating. In a passive house, that would never happen, right? So it's pretty cool to see how these things come together and do become synergistic benefits. Okay, so this study was for a hotel, neither of these two buildings, but a hotel similar in scale to the 79 King Street. And we were able to see that from the code version down to a passive house version, we were able to reduce the energy use substantially. And by moving to timber, okay, we had an improved envelope scenario in the middle, and you can see, okay, we saved a bunch of money. We cut the energy bills in half. With the mass timber, as well as the passive house, we were actually able to reduce the R values substantially and get better energy results. In other words, we strip away those thermal bridges, and we needed less continuous exterior insulation, and we got better annual energy results. Alrighty, so there are lots of synergistic benefits in terms of reducing cost, reducing insulation for the same performance, reduced depth of fasteners and cladding support associated with the insulation. You don't have to go anywhere near as far with thermal bridge mitigation strategies, the smaller heating and cooling system, speed of erection of the building, the reduction of finished materials. It's easier to achieve the air tightness. That's another feature of using CLT if you're using it for walls as well. And the window installations get nice and simple. So these are just some of the things that have been really beneficial to us. Now, I've got enough time left, I think, to talk about the bigger picture. All right, is mass timber a path to decarbonization? Now, all of us in the architecture, design, building development field see a shiny object, a beautiful thing like mass timber, and we leap for it. We're like, oh, terrific. Well, we let someone else leap for it first, and then we want to be second, right? But in any case, you know, when something comes on the market like this, there's a kind of exuberance, like, oh, we got to try this. This is awesome. Let's do it. Okay, mass timber is beautiful. It's biophilic. It's better for the mold risk. It's better for passive house. It's better in every way that I can think of. But will it save us from climate change? Is the question. And I wanted to just do a little bit of exploration of this topic because I know that if we corporatize and industrially scale something like mass timber, there aren't going to be many trees left if we keep growing at the rate we're growing. So Sean, that's another nod to regenerative economics. Like, what do we really have to do, right? So I asked myself, and our team asked ourselves, like, what is mass timber? How does it work? How sustainable is it really? So this is just an exploration, a question. I'm not trying to like pop any bubbles or dissuade anyone. I just want to talk through some issues. All right, number one, not all forests are created equal. Never, ever, ever use wood coming from an old growth forest if you can help it. Old growth forests are incredibly biodiverse and dense in the many functions of a forest, including carbon sequestration, but not at all limited to carbon sequestration. It's a habitat for so many other things, all of which are vital. Now, these are obviously not old growth forests. They are both managed forests, but not all management is equal, created equal, right? So in the one on the left, it's a plantation. You get very low biodiversity, low carbon on the land, but high carbon, fast growth in the wood. Okay, so you're like, oh, the trees are sequestering so much more carbon. Yeah, but you denuded the understory, which actually stores a ton of carbon. And the soil has much less carbon in it as well. And the ecosystem services of those trees are a fraction of what it would be in an old growth forest. So yes, you can sequester carbon in the trees, but let's not only look at the carbon in the trees because it's a whole ecosystem we're looking at, right? Now, a managed forest, selective cutting, has moderate biodiversity. Well, it has better biodiversity. It has moderate carbon storage in the wood. It's not quite as concentrated as a managed plantation, but it has much more carbon stored in the ecosystem below the canopy of the trees. And it has much better ecosystem services in terms of cleaning water, cleaning air, and providing oxygen. So the extraction of forestry products is moderate and consistent, but it's not as high as if you did a plantation. In terms of net benefits, if we're talking about anything we could ever call regenerative or really even sustainable, it has to be selective cutting and managed, not plantation farming. Now, where you have 0 trees and you do a plantation, that's a net benefit. So it really depends on the current ground use and then what you do with it. If it's already a forest, don't destroy it. If it's not a forest, if it's been degraded land, then sure, you can plantation farm it. So there are a lot of different questions come into whether or not we should be taking this timber or how much of it. Are certifications valid? Like this was a certified forest and it's a clear cut. Like that doesn't feel good to me. And it's an old growth. You can see the size of that tree. So the goal ultimately is to do optimal climate smart forest management. So we're going to optimize for carbon sequestration in the wood, adapt the management for resilient forest ecosystems. And we want to make sure the productivity is good, but it also has to include the ecosystem services. We can't just say we need more board feet of lumber. We have to say, oh, what's the balance between board feet of lumber and water and air, et cetera, and habitat. Okay, so I'm not going to go into this in detail, but the point is there are like 6 or 7 different models for modeling the carbon in a forest ecosystem and our use of it. So there are all these different ways to account for the carbon balance. So yeah, we can say, isn't mass timber great? Well, there's not even agreement necessarily on how much carbon is being released or stored or retained in the landscape. So there are ways in which you look at the growth of the tree and you say, okay, there's our carbon sequestration. And then we cut it down and it's nothing but release from there. And hopefully at the end of life, you haven't emitted more carbon than you've used and then has been sequestered when you grow the tree. Of course, you have industrial processes along the way, so there's still a carbon footprint, right? So this is kind of aligned with cradle to grave because you like take the tree and you start accounting your carbon emissions from there, but you say, oh, but I sequestered the carbon in the first place. There are other models where you say, okay, after you cut the tree, then there's a balance, like you're emitting carbon through manufacture, but a new tree is growing. Well, how many new trees? How well? Of what varied species, et cetera. So this accounts for deforestation because like you have to be growing the new tree. The last model is just like, I take a tree, it already sequestered the carbon. So if I cut it down, I'm good, I'll just use it. But you could clear cut everything and you wouldn't have a solution there. So this second model allows for you to pay attention to deforestation. And this is just one other example, and I'm going to stop with this sort of mind-numbing complexity. But the idea of like having an ongoing harvest across a large parcel of land and understanding the rate of extraction and the rate of production and the regrowth at the same time, like, okay, is this the best way? It gives you a supply area and a period of interest and tries to consider it holistically. Still, none of these have accounted for habitat disruption. None of these have accounted for any other of the critical variables in the natural world that we should be paying attention to. But there's an army of people working on these accounting methodologies, and it's great. I'm hopeful. But I just don't want us all to say, oh, mass timber, it's great, let's do it, and then destroy the forests by doing so. Okay, the point of everything I just said, which I know is kind of exhausting, is that we need to understand what our socio-metabolic rate is as a society. You can't take more from the world than the world can generate or absorb, right? So if we're going to do a socio-metabolic analysis of just a forest, that's fine. We can put our boundary analysis, our boundary of analysis around how big a forest, is it a bioregion, what have you. But one way or the other, we only can take as much as we can take without degrading the system's regenerative capacity. So mass timber is not a one-size-fits-all solution. It is not a magic carbon solution. I'm going to skip over this one to the next one. If you have a forest grow and then cut a bunch down, and then it grows again and you cut a bunch down, and it grows again and you cut a bunch down, and you store that carbon in products, you could say you are continually sucking carbon out of the atmosphere and storing it in building materials, right? That is true. Just looking at the time here. Unfortunately, since we've wasted most of our runway for a soft landing, in terms of climate, because now we only have a handful of years left, where when we first started talking about this, when I first met you, Zach, we probably had 20 or 30 years, right? And now we're down to like, oh shit, maybe it's 10 years. We've got to turn this whole Titanic around. Okay, well, if this is a 20-year time span that I've put the red and the blue bar around, like if you harvest the forest in a way that degrades the carbon um, regenerative capacity of that forest, you've sort of actually done harm, right? So you have to like consider the time frame, not just the methodology, because the time frame is now short. So wise, sustainable harvesting of timber is good, and one that doesn't disrupt the ecosystem as a whole is very important. And then, yes, indeed, we will store that carbon and it will be a net benefit. And I'm just reiterating here, the value of the wood in the tree, actually, most of the value to the planet is from the tree staying in context, right? Because there's moss growing, there's lizards, there's like insects, there's like cleaning all the water, everything. Like, so actually the tree has the most value if you leave it there. So if we take it, we have to take it mindful of what can be done regeneratively. Okay, so I'll stop beating that horse. In 11 East Lenox, we found that we were able to reduce from the steel and concrete structure down to the mass timber. We were able to achieve pretty significant reductions. There are 4 cases here because we are comparing refrigerant load as well. But you can see that from steel to wood is all a pretty good reduction. Now the question is, could we account for the carbon? The dark blue at the bottom is if we allow ourselves to account the carbon storage in the timber that we used in 11 Lenox. And if so, then it would knock off, some of our embodied carbon or some of our operational carbon here. Above 0 is operational carbon. It's embodied and operational carbon. Below is storage potential if it's sustainably harvested. You can see that we have a stack left, even under the best case scenario, of operational carbon over 20 years and embodied carbon, okay, in this stack here. The solar is yellow. And so we're able to reduce our total carbon gap, I call it, right? Between the carbon storage and the solar, we're reducing the size of what's left. And so now this yellow, pale yellow band is what? Less than a third of the original building? That feels like progress. So it didn't fix everything. It's a vertical building, so there are a lot of people under there. So there's a lot of operational carbon because people are doing stuff like watching TV. But we've made serious headway. We did a similar study on 79 King Street, and we found that the carbon storage is this green negative. Our original plan, it was this light green. And then we thought, look, if we could do the podium in mass timber as well and turn the studs from light metal into wood, we could get double the carbon sequestration. If we did so, it would equal approximately 12 years of a FIAS project with PV. In other words, we would have sequestered 12 years of operational energy worth of carbon emissions up front. So in that remaining 12 years, how much more can we electrify? How much more can we clean the grid? So this is actually starting to trend towards a zero carbon solution in my mind. Okay, so this is my last slide. And hey, I'm 6 minutes ahead, Kim. You said 40 minutes, even with the snafu. So I'm happy to take questions, but basically I wanted to close with this. Look, this is using mass timber, using biogenic carbon-based materials is a very long and rich human tradition, right? Like it's what we've done from the start. I think we need to get back to it. I think doing it in the context of Passive House is even better. And I think doing it also in a bioregional context with localized networks of exchange and reciprocity, if we do that, if we use mass timber in that way, we just might have a climate solution. Because whatever the technology is, it has to be woven together with localization, in my view, networks of people with shared values like ourselves. Like we're across the country, but we could have sort of cosmo local, like shared concepts that we practice locally in a region, but that we share globally, right? And if we do that and even start to move our economy, at least some parts of our economy, into a concept of reciprocity and alternative exchange, other than the one algorithm that governs us all, which is the profit motive, right? Like, it's not only a motive, profit and extraction is an obligation of capitalism. You have to promise a rate of return to move capital towards the solution. Now, if we're able to do some of this locally with reciprocity, that could be a socioeconomic climate solution that is embodied through biogenic carbon materials and deep, deep conservation of passive house. So with that, I will say, that's it. Thank you very much for listening, and I'm really happy to take questions.
All right, Michael. Well, guess what? We're all just going to take a deep breath. We're just going to let that all end because that's one of the best 101s that we've had in the accelerator. That there's some amazing nuggets for us to just pause and reflect for a second because we're going to just check out what's going on with our accelerator community. So, Kim, I'll send it over to you real quick so we can see what's going on. But whoa, that was a lot.
Awesome. Thank you. Yeah, Michael, that was fantastic. Thank you so much. I'm going to go through a few events. And first, we want to thank our newest sponsor for jumping on in support of the accelerator. We have Oakley Custom Woodworks. They do beautiful work. Link is in chat if you'd like to check them out. And we'll move over to our podcast here. We have 2 episodes to share. The first is all about insulation and overheating risks with a building scientist out of New Zealand. And the next episode is with the team from Cycle Architecture and Planning, all about transforming multifamily housing. Next up on Passive House Accelerator Live next week, we have Sean joining us as a presenter. Really looking forward to this one. He will be joined by the team at Ryder Architecture to talk about lessons from Timber and Harmony, a project in Vancouver. There's a link in the chat to check out a little bit more about that as well. And we have a component spotlight featuring Rockwool coming up on March 18th. This is all about designing for optimal acoustic performance. And this is one of the events that you do have to register for. So check out the chat for that as well. Next Thursday, an event we are very hard at work on. We have Reimagine Buildings Multifamily. This is a 4-hour conference, fully virtual. We have 16 speakers. Very solutions-focused program. We have AIA, FIAS, and PHI credits available for all 4 sessions. And the final hour is a full-hour AMA with a great panel. So we hope to see you there. Check out the program in the chat. Bring your whole office. We'd love to see you next week. Next up, we have the Building Energy Boston conference taking place. I believe Michael is presenting at this as well. This is March 13th through 24th. We have the International Passive House Conference taking place in Essen, Germany on April 24th through 25th. And submissions are open for the New York Passive House Regenerative Metropolis Symposium taking place in September. I believe this is open until mid-April. Taking place on the Reimagine Buildings Collective. Michael will be joining us for an hour-long AMA this Friday, so you can bring all your questions for him. We have a full hour set aside for you, as well as a few other events coming up. And just a reminder to any Reimagine Buildings Collective members that the multifamily conference is free for you, so you don't need to register for that. And a quick thank you to our sponsors. We have 475 High Performance Building Supply, Ingui Architecture, Partel, Rockwool, Zola Windows and Doors. We have our champion sponsors, Bowiso, Cascadia Windows and Doors, European Architectural Supply, Intelligent Membranes, Icon Windows and Doors, LG, Proseco, and Source 2050. Our patron sponsors include Building Type, Brennan, Holzarm Systems, Innotech Windows and Doors, Lamelux, RDH Building Science, Reservoir, and Sanderson Sustainable Design. And our stakeholder partner is the New York State Energy Research Development Authority. All right, over to you, Sean, and we will kick off the Q&A.
A couple points too, Michael. I feel a little bit proud being here in BC, where 60% of the wood products that US uses comes from our province, and the fact that we're converting a lot into value-added products like DLT and CLT, it's pretty great. And the fact that these are family-owned businesses that are 2 to 4 generation-owned businesses is a very different business model. So quite proud that we're making those move and then tying into the Passive House movement. So some great movements in the Pacific Northwest and here in BC, and it's great to just land some of those comments that you talked about. That hey, there is things happening in our industrial movement and not always focused on the capitalistic part. So great portion. Michael, we're going to kick off with a bit of an easy one. Brent wanted some clarification on the doors. Brent, want to jump on and ask any other questions? Brent doesn't come on. The question that Brent had was, what was the door brand?
The door brand. Oh, it was all Amberline. Amberline provided UPVC windows, UPVC balcony doors, and the aluminum storefront and the entry doors. So everything was Amberline. On most of our other projects, we are being forced to procure doors from Conair or YKK or one of these other storefront companies. Not to badmouth them, but they don't have the same obsessive concern for thermal performance or airtightness. And not only that, we've found that often they have a project of scale, like the Barry Farm District Geothermal project I showed you. We're the Passive House consultant on the first 2 multifamily buildings and 93 townhomes. Okay. And so that's a lot of stuff, right? And so it's a big enough project. They have a special door hardware consultant. And the door hardware consultant says, oh, no, we can't use that because it doesn't have our key mechanism, it doesn't have blah, 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 blah. And so like things that I never would have thought to think about become some significant obstacles.
Yeah.
Amberline was able to provide us with what we needed on that project. And I was very grateful for that because then I didn't have to run a whole bunch of extra models to see if anything would work. Now, on a project of that scale, on a project of the Washington, D.C. Barry Farm scale, like a whole first floor, a storefront can crash the model, right? Even their best one. And so we ended up using combinations of Alpin, but then Alpin doesn't have a door, so we had to go with a YKK door or a Conair door. So it takes a bit of work to work it out.
Yeah, it's so important to have, not just specialists on board, but just having that in-depth knowledge to be able to just deal with the details and the fact that they
Right.
know the challenges you're working on and be like, hey, before you ask the questions, we can offer you this. And does this work for this particular issue on your building and other different scenarios that they've already run through another high performance project? So it's
Right.
great to have a team just, debate or having conversations of, the minutia that we get to in our projects. So that's fantastic. All right, Tim, if your mic works, and Brent, chime in if there's any other comments you had, but hopefully you're happy with that. Tim, do you want to ask your question?
Sure. You mentioned at the beginning that you're doing a lot of affordable housing work now, but I didn't catch whether either of these 2 projects were affordable housing buildings or if they were market rate.
No, actually, these are market rate.
Okay.
Now, of course, and Jeff, you want to jump in there?
Yeah, thanks. And I know 11 East is market rate, but we, Tim, originally conceived of 79 King as for senior market rate, but it really didn't pencil. And that's the third leg of the stool, the economic viability of sustainability that has to be met. And Michael, you really put that out there properly. We started this together in 2021. We're still at it to try to solve that third leg. And by upzoning, we're getting a lot closer. And by dedicating at least a portion to affordable and making it mixed income, we're going to get there. So this will be a mixed income with workforce housing, some market rate, some deeply affordable, which is a mass housing kind of formula to make it happen.
Great.
Tim,
Thank
what was the reasoning behind your question? I'm just curious, just because I wonder about this all the time.
Well, I think right now, of course, changes in federal policy and what this government thinks about affordable housing could undermine this. But market rate buildings are not happening with as much as they were a couple years ago. So, I think our focus is that there's more work in affordable housing. I've done a little of that, and just wondering how much these technologies, whether it's mass timber or passive house or combined, can actually work
Yep.
in affordable housing buildings where there are real cost constraints that are set by federal policy.
Yep. Sean, do we have a bunch of questions? Because we could go on about that forever, but we should perhaps hear what else there is.
We got a couple more, but I think there's a good point. So if you want to spend a couple more minutes just discussing that, because I know the segue you're going to go into, and I want you to go on it.
Well, I just think that what we have seen is that, first of all, people were building better affordable buildings than they were luxury buildings because the state is actually watching and say, oh, you get the common wheel benefit of taking tax credits. We're going to hold you to a standard. And so I've been advocating within Maryland for getting passive house into the affordable housing QAP. And they're like, all the builders are saying, we already build so much better than when we do and we build luxury homes. Why are you doing this to us? Which is ironic, right? It's really ironic. Now there's smaller units, but now, what we found, what I don't know if you've seen the data, Tim, from Pennsylvania over 3 years of affordable passive house building. But the first year was a scattershot. Some were more expensive, some were less expensive, some were historic and radically more expensive, some were just stick built and they screwed up and it was more expensive anyway. The data was all over the map, right? But there was a negative 2% increase for passive house. In other words, it was 2% cheaper to build passive house on average. Now, I was in some of the rooms when people were pricing those buildings. And I would say, okay, I got 3 wall types for you. Tell me which one is most cost effective and we'll go with that. And they're like, Michael, you don't get it. The budget's the budget. We have to say it costs this. Shh. So I don't know how many people lost their shirts on that. I don't know how many people had to take a haircut. But over 3 years, data came out that I would place some faith in, which is that the first year it was 8% more expensive. And I'm not going to get the numbers exact, but I'll give you the general gist. The first year was 8% more expensive. The next year it was 5.5% more expensive. And the third year was 3.5% less expensive to build passive house than conventional construction. Why is that? Now, everyone here is already shaking their head, like Sean and Jeff. And if you do passive housing, you get into the mode of systemic thinking, the building as a system, looking across silos to find complementary benefits, like the synergistic benefits of mass timber and passive house, as just one example. If you think across silos, structural engineering, mechanical engineering, building insulation, you actually find efficiencies that no one's paying attention to in a design, bid, build, bang it out, conventional construction. That, I believe, is real. So that's just like an answer to, none of us know what's going to happen with this government, with affordable housing policy, but we do know that you can actually make buildings far better for equal or less. Now, sometimes it's going to cost a little more, but we haven't even accounted then for the 60% energy savings over 40 years. I mean, give me a break, right? It makes sense.
Which helps with, long-term affordability, which is
right.
Has to be part of the equation. And
exactly.
Yeah.
Did you want to take another question, Sean, or are we done?
Yeah, well, we got one more.
I just want to add real fast. It take me 10 seconds, and that is that affordable housing, the affordable housing sector has been a leader in passive house development. The initial wave is fancy single family homes, and then affordable housing projects are I don't know if they're the majority of projects and square footage, but I wouldn't be surprised if they were. So just wanted to add.
Yeah, and just to come back to the cost, I mean, we just have to acknowledge, like Gord Cook's line, it's the dumb tax. The more that we're learning how to do this faster, the more we're sharing, we'll reduce the cost. And the fact that we're now seeing mass timber projects competing against concrete, we're seeing passive vintage conventional. We're at a point where we can build these zero carbon buildings every day now, and we're here spreading the news and sharing our details of just how to get it better. And like Michael, there's some amazing nuggets that we could have into a construction tech show just about the balcony details and window details you shared. Like those are some easy things to steal for future projects. And I'm super lucky. We've got a mass timber hotel, and I'm like, as soon as this, Kim, you got to pump this slide out by the weekend because on Monday we need to copy and paste Michael's and Jeff's projects here in DC because there's just some simple details. We just copy and paste now. It's fantastic. So Tim, that helps out with the overall cost. I think we just had one quick clarification question on the ample line windows. Sorry, Nick was next, and we're a little bit over, so we'll just keep everyone for maybe 5 more minutes.
Yeah,
And
I'm good. I can stay as long as you want. So if anyone wants to keep chatting, I know you guys probably have to wind it down, but I'm cool. So go ahead.
Nick, you had a quick question?
Yeah, so what I initially posted was just a kind of a clarification point to add on to Michael's talk about habitat, is that erasing stuff like grasslands habitat that in the US stored, feet upon feet of carbon-rich topsoil, is that a lot of that got plowed and planted as tree plantations here in the South.
Right.
So it kind of, there's a whole unseen number of carbon sequestration that's gone when you change ecosystems like that. But I did have an actual question on it was I think it was the 11 East Lenox project on the structural weight of the mass timber project versus what would have been a conventional podium. Is when in that systemic kind of synergistic thinking was the decision made, or that kind of discovery, that aha moment of, oh, well, we actually don't have to do as much structural foundation work with this site? Was it something that said, oh, we should go with mass timber as an option, or was it something that just confirmed that that was the best choice for that site?
Okay. Yeah. So I'm not going to be able to give you a full answer. We'd have to go back to the developer and the architect and their early conversations and their geotech analysis.
Mm-hmm.
I do know that the foundation detail was evolving as we were working on the project. So they had made a decision. They wanted to do mass timber because they thought it was cool. But then they realized that they could actually do if they hadn't done it, they wouldn't have even been able to build it. So it turned into a real success. Now, I don't know what the weight difference was, and I don't know exactly when it was decided, but I know the evolution was ongoing, and we just kept finding more benefits. So that doesn't really answer your question, other than to say they were motivated to do passive house, and they were motivated to do mass timber. I don't think they realized how well it was going to work out.
And now we have all this great information from that we can use trying to sell a client on this same approach. So thank you for your presentation.
It should be said that if they hadn't been looking, it isn't like most of our work in passive house and things like mass timber. Like if you start with a mindset towards holistic thinking, and if they hadn't started with that, and if they hadn't known to connect the structural engineer to Nordic Structures, the mass timber provider, to the architect, to the passive house consultant, if they hadn't known to have done that, this wouldn't have flown. So that is very much to the point, Nick. Thank you. Also, with respect to your earlier comment, if I may, you guys can just shut off my mic if you need to. But it's habitat, it's soil carbon, absolutely. And when I said, the capitalist system has one algorithm, right, which is extractive rates of profit, that is what moves capital. I'm not being partisan or ideological. It just is what the system is. It's you don't move capital towards a project unless you can say, I got this rate of return, because the capital just won't move, because everyone has a fiduciary responsibility to yield the highest rate of return, et cetera, et cetera. Now, let's put a pin in that and say, Michael's a crazy anti-capitalist lefty nutwing, or wing nut, sorry. Wrong. The truth is that indigenously managed forests return greater year-on-year yield of biodiversity, wood products, water cleaning, and air and oxygen generation year on year with a truly sustainable approach to forestry. The indigenously managed forests in the United States are more profitable. Okay? But markets are set up with rules of how you play the game. And when your rule is a quarterly rate of return, and you can be venture capital and buy it and extract the wealth and destroy it and say, hey, I made a big profit, the rule is wrong. It's not capitalism itself or a system of exchange. All humans have always done markets. It's that we set the rules with incredible short time horizons and incredibly narrow boundaries of analysis. So yeah, don't get the impression that I'm anti-market, or, I mean, I am a wingnut, but not in that way.
Well, Michael, we all are. I mean, everyone that shows up here, and the fact that we're not breaking the rules, but we're bending them and also redefining them, is fantastic. So we're up for questions. But if you didn't get your question in, and or you're just absorbing all the great things that Michael discussed here, he will be on the Reimagine Building Collective's Ask Me Anything this Friday, so you can hop on there and ask him more questions. Michael, you said a lot of great stuff, but I always just appreciate some of the simple things. When we say mass timber is cool, and that's where we started with, those are some of the easy ones. When passive house becomes a starter conversation because it's cool, we get past the hurdle of, oh, what is this thing? What is mass timber? What is passive house? And we allow people like yourselves to just explore and have fun. Your slide deck was fantastic. The 3D modeling that you're using in your projects is fantastic. And again, I'm inspired, and the fact that we got to discuss regenerative design and methodology is
Yeah, we snuck it in, right?
it was fantastic. Hey, we have to, again, how we move things, we just slide the good stuff in. So, everyone, we're gonna wrap it up. I will see you next week because I get to go from host to presenter as I'll be talking about affordable solutions with a passivist project that I was involved with my good friend Zena and Adam at Ryder Architecture, and that's going to be talking about Brightside's Timber and Harmony. So, my friends, we'll see either 2D, 3D. We look forward to seeing it soon at some point. And Jeff, the Mass Timber Conference I know is coming up. I'll try to be there to talk more about your amazing projects and hopefully connect with this great community. So enjoy the rest of your Wednesday, everyone, and we'll see you soon.
Thanks, everyone.
Bye, everybody. Take care.